We'll be dealing with what we called leveraging 2.5D and multi-side milling power the best way. Well, actually what I'm going to be doing is I'll be taking a part even before we open up our SolidCAM project, and I'm going to start actually programming this entire part, the part actually that you see on the screen. I'm going to also be creating the stock, and what I mean by creating the stock is not what you would think we're creating automatically around a box around the part itself, but actually using a stock as the way we may have it formed in our tool shop. I'll also be using a fixture and defining the fixture and working in an assembly mode to show you exactly how I place the fixture. And also I'll be showing you a little bit when I create the stock, how I actually do it using configurations and so on and so forth. As usual, we can always ask questions during the webinar. Excuse me. All questions at the end of the webinar, all you have to do is click on raise hand, and in the questions area, write down your question. And don't forget, when you finish writing down the question, you must click on the send button, and then I'll get the question that you actually wrote down. And at the end of the webinar, I'll go through them and answer them to the best of my abilities. Okay, so let's start with this part as we see them on the screen. And before I even start with SolidCAM itself, I'm just going to start looking at the part itself and say, you know what, this is the part I want to machine, and I have to do work on this part. I have to do it from this side over here, plus I have multi-sides. I have to as well. I have to do it on this side, machine this side over here, this side over here itself, as well as this side, and even the back has to be machined. The under part of the of this part does not really have to be machined. That actually I'll just put in a regular conventional machine, and they'll just remove the excess material. There's no actual real machining that has to be done on that. That requires CNC. So what I want to do is I'm also going to be using a fixture. The fixture that I'm going to be using actually looks like this. I'll be using this fixture because I'll be working actually on a 5-axis machine. Working on a 5-axis machine on the part will allow me to do all of my operations needed in one setup, all on this particular, fixture. So let me go back to the actual part itself. And what I'd like to do beforehand, before I start the SolidCAM project, is actually create my stock, because my stock actually has to fit inside that fixture. And of course, I know what my fixture is. I know the measurements of my fixture. So I'm just gonna first start working in SolidWorks itself. So I'll create my stock directly on this part here itself. And since I like working in configurations, I want to keep my stock in the different configurations. So I'll go to configurations and add a new configuration, and I'll call this configuration stock to keep it separate. Okay, now in this configuration, I'll create my stock itself according to the part, and I'll work on this edge over here, on this surface over here, and start my sketch. Now, since my part is exactly in the middle, I have it made exactly centered. That's the way I happen to like working on the part. I'll just create a little box around the part itself. Again, centered, and I'll actually take my measurements off the edge of the part itself towards the edge of the stock. Let's say 2 millimeters. This way, if there are any changes in the part, the stock will change as well. Okay, so I'll change that, and let me just go into my features, and we'll do extrude boss. Now I want to keep this as a separate part from this, so I'm going to get rid of merge results to keep the results separately from the part itself. I have to keep it as 2 separate bodies, and I'll go up 2 millimeters towards the top, as shown over here, And in direction 2, I'm going to do offset from surface, from this surface down here. And what I'll do is I'll do a reverse offset. So it goes past the part. And since I know what my fixture is, I know I need an extra 20 millimeters at the very bottom. And I'll accept that. So what we have right now here is we have our stock in 2 separate bodies. Now I like to keep my stock as transparent. So I'll just open up where it says here 2 bodies, solid bodies 2. And on the stock itself, which is this, I'll just right click and say change transparency, so we have our stock as shown over here. We'll just continue now because I have to make this for my fixture over here, as shown before, to actually fit inside over there. So I'll take the part, let's go back to the part, and I'll continue by just doing a little sketch on this side over here. And let's see, we'll take I like working with a center line over here. It makes it a little easier for me. So I'll put a center line over here. My mistake. All right, I'll put it all the way down over there. And let me just continue now creating a regular line starting from here, going all the way to here, back down to here, to this point over there, and back over there. And now I'll grab everything I did, including the center line, and just give it a mirror image as shown over there, mirror entity, so I have it now on both sides. We'll have our dimensions, the way I know my fixture is. I'll put this at 35 millimeters. I'll put the height that I need over here at 15 millimeters, and my angle over here will be 60 degrees, sorry, as shown over there. And then I'll cut this extrude cut through all. And that's how my stock will actually look when I actually put it towards the machine to fit inside my fixture. As you see, I did this in 2 separate configurations. So I have my standard part and my stock. Now, if I want my standard to show it without the stock itself, all I do is, while in standard, I'll just go to where I created my stock itself, right click and suppress it. Okay, now both actions are suppressed, and you can see we have our 2 separate configurations, our stock and our standard part itself. I'm going to save this, and now let's get ready to start working. Okay, we'll start our SolidCAM project, and as I said, I'm going to be working in a 5-axis machine, so I'll start my new project of milling. Let me save it, sorry. And we can see what part, the name of the part. We can see what the part is actually I'm taking. You can see that over there. And we have our part inside, and we're ready to choose our machine. Since I'm going to be working in a 5-axis machine, I'll choose in this particular case, I'll be choosing my Hermiller machine, which is a 5-axis machine. And I'll start defining my coordinate system. We'll define our first coordinate system. I'll click on this surface, and I, in this particular case, would like to have it in the exact center of the part. So I have this over here in the center as shown over here. And I'll just click on OK for my first home position. Now, I like to add another home position because, as I said, we have multiple sides. So, by the way, as you've noted, we do not have to right click and say add. All we have to do is just go right over here and just click on add right here, and we can add another home position. I'll click on this surface over here. Now, I would like to have my Y actually going towards the back of the part, since I want this facing me when I'm machining. So we'll just reverse we'll flip it around Z, so that I have my Y towards the back of the part. This way, with on the machine, it'll be facing me exactly the way I see it right now. I'll continue now and create another home position. I'll create one over here, on this surface over here. Again, I like to have the Y going in the back, so I'll just flip it around. Accept that. And one more, I'll do another one over here, on this side over here. That's fine exactly the way it is. and my last one will be on this side over here. So I'll just create my one more position. And the idea behind this, I'm actually going to try and, during the time I have here, to actually program this entire part exactly the way you see it. Okay, so we have all our home positions. Now that we have that, you can see we have 5 separate home positions. Our first one, and the rest of them over there as well. Okay, now I want to create my stock. Since my stock is actually built in already into my part itself, so when I go to create the stock, instead of using the option of defining it by an automatic box, I'll use the option of 3D model. Now, also, since I created this in a configuration, I can actually choose which configuration I want right over here. Instead of standard, I'll take stock. And then I'll just click on the stock itself. And if I do show, if I click on show, you can see that we have our stock. This is the exact stock that we're going to be using. Okay, so I'll accept that. And the way I have my system set up is that my target was automatically defined beforehand as I was creating the part. Okay, now let's not forget, if I'm doing an iMachining operation on this, I need to add my iMachining data. So let's add my machine database by clicking over here and adding the actual machine that I need over here. By the way, this step that I'm doing now in SolidCAM 2014, you won't have to do this anymore, because this will automatically be done inside. All the information will be actually together with the controller itself. So this window won't be here anymore. It'll automatically be done as you're loading the part. So this step will be taken away. You won't have to do that anymore. Of course, we still need our material database. And let's just choose, in this particular case, aluminum. I'll use 61 TS, and we're all set. Now we're ready to start machining. Well, it's not really true. I actually can start machining, but what I'd like to do is I like to add my fixture now. The reason why I like to work with fixtures is also, one, to see exactly how it's going to look on the machine. So to avoid any crashes into the fixture, I can see everything that's going on, and it'll give me an exact picture of how I'm working inside my machine simulation. So for that, I'm going to open up my assembly. But before that, since my fixture that I need, it has to be mated towards my stock, I'm just going to open up my stock over here, make that active. And now I'm going to go in my assembly and insert my large fixture, since I do have it still open, so it's already there. I have my fixture, and now all I have to do with the fixture is actually just mate it inside to the part itself. So we'll click on mate. All of this is being done inside SolidWorks itself, and just in the assembly mode at this point. And I want to have that surface towards this surface over here. I would like to have this surface towards this surface over here. Now, what I'd like to also do is I like to have this sitting exactly in the middle of the part. Now, the way I like to build my fixtures and my stock is I like to keep everything centered. This way, mating it also makes it a lot easier. So the way I'm going to continue my mating is I'm going to go into my part itself, my design model. And in my design model, you can see I have my my working plane over here. My right plane is exactly in the middle of the part. I'll choose that. And if I open up my fixture, if I go to my fixture planes, you can see I have the same plane over here exactly in the middle as well. So I'll just make the two, and what you have right now is exactly sitting in the middle. Now I've mated my my fixture towards my stock and everything is in place. Well, now what do I have to do? I have to define my fixture. I can define my fixture by just going over here and defining my fixture. Right click, define fixture, and just click on the fixture itself as shown over here, and my fixture is now defined. Okay, as far as my machine though, I still have to do a machine setup, because this way, if I have to do a simulation right now, the machine has absolutely no idea where this is sitting towards the 0 point of the machine itself. So we have to define that in our machine setup. To do that, right click on operation, go into machine setup, and you'll note that my fixture is here already. It's already inside my machine setup. If I click over here to give a preview of my fixture itself, you can see that it's over here. All I have to do is put in the value of the top towards the actual 0 point of in the Z level. Of course, everything is sitting exactly in the center. So all I have to do now is right click on Z and pick Z. I'll pick it directly from the bottom of the part itself, the bottom of the fixture, and that value is automatically put in over here. Now we're ready to start machining. One more thing I do also like to do. Since I do like to turn off every now and then, switch back and forth between stock and standard, since my fixture is mated towards my stock, I'd like to have the fixture also part of my stock configuration and not inside my standard configuration. So I'll go back down over here where I actually have my fixture. I'll right click on it and I'll say configure component, and I'll say it as follows. In my standard mode, I want this to be suppressed. Click on OK. So now when I go in here and change this to standard, we see just the part itself. Back to stock, we have it this way. Okay, let's start machining the part. Now, the first thing I'd like to do is actually work on this side over here, on the very top of the part. And the first thing I like to do is do a face mill. So let's do a face mill itself. Wait a second, what about the tools? Well, the way I like to work is I like having, since I like to have this as a good practice among the customers, is since we have tools that are very standard all the time and tools that we always use. So instead of defining them every single time I start a new project, I like to keep a tool table that has all of these tools in them. And in fact, in my case, what I do is it's actually defined already inside my post. So this way, whenever I load this machine, my tool table is automatically here. If I double click on tool, you'll see that we have a complete tool table of tools that I always use exactly over here. So I don't have to go and create new tools. Now these tools are now part of this part project. Okay, so as I said, I'm going to start my first operation, and 2.5D face mill. Okay, we'll start our face mill operation. We have all our Mac positions. I'm going to position 1 is what I'm going to be working on right now. I'll create my geometry. Now my boundary that I'd like to create will be around the stock itself, not around the part. The stock is a little bigger, so I want to use that. Since I created my stock as a 3D model, I can go immediately over here when it's clicked on model, just to the arrow over here, and choose my stock as shown over here. Now you can see that my boundary is automatically according to the stock of the part itself. I'll just accept that. And my tool. If I go into my tool, I'll select my tool. I like to have my face mill. I have a face mill that's 120 millimeters. Now, if I make a change, it'll over here to a tool, it'll be only for this particular tool table. I like to have this at 125 millimeters because I saw that's exactly what I have. No problem changing it as I'm going along. I'll select it. Oh, note one more thing. Every tool that I have over here, no matter what tool I'm using, every single one of them has a holder. And I advise everyone also to use holders when creating a tool. Even though you can work through the part technically without having a holder on it, it's always good practice to have holders with your tools itself. The reason for this is very simple. One, again, in your simulation, you'll see exactly how far down your tool is, if there's any interference with your tool. And another reason for that is when creating your tool sheet later on to give to your setup person, all of the information as to what type of holder, how far the tool is sticking out of the holder, what type of tool, everything will be written down inside that tool sheet automatically. So he doesn't have to ask you every single time what type of holder he needs, what kind of tool, how far down to, how far outside does the tool have to be. All of this information will be inside the tool sheet. Okay, so I've selected my tool, and let's now deal with my levels. My upper level will be according to the stock itself, so I'll just take the corner of the stock itself. Note, picking the corner would also keep the associativity to the part. The face depth, I'll just click on the corner of the part itself, and you'll see the associativity is taken there as well. Now, I'm going to leave my step down in one point at 2 millimeters, since it's aluminum and I can do it in one step down, so I have no problem with that. Now let's go to my technology. And honestly, I really don't want to do it in one step. I like to first leave a floor offset of 0.2 and then do a finish cut for a nice smooth finish. So all I have to do is floor offset and then put my finish. Now, since my tool is also large enough to cover the entire stock over here, so what I'm going to do is, instead of hatch, I'm going to put this at 1 pass. Let's run our simulation now, and we'll run it using solid verification inside our host CAD. And I'll do this one step at a time. You'll see the tool actually goes down, across the part, back up, across again, and taking off the last 0.2 millimeters on the part itself. Let me actually do this now using machine simulation. Using machine simulations can give you an exact view of exactly how it's going to look on the machine itself. Of course, you have to have machine simulation for that. Okay, as you can see exactly how my fixture is sitting on the machine itself. You see it's sitting exactly at the right height because I did my machine setup. I gave the information of the height of the part itself, so everything's sitting correctly. All I have to do now is run my simulation. Let me just do this one step at a time. Step forward. See the tool goes down, across, down again, and now finishes the part itself. Okay, now let's go to our next operation. In our next operation, I would like to work on the outside of the part itself. You know what? Outside, let me do this using iMachining. No problem. So, we'll start our iMachining operation of 2D. And again, we're still working Mach 1 position 1. And let's create our geometry. I'll go into new. Now, I need my stock for this because I want to have my outside boundary defined according to the stock. So again, I'll go into my configurations, changes to stock so I can see the stock itself. Okay, my first chain is from the outside. I'll do auto constant Z. My second chain is, I'll choose the bottom over here, auto constant Z, and we have our 2 chains over here. Now the first chain has to be marked as an open chain. So right click, mark chain as open. Okay, so we're all set as far as that goes. Now let's go into our tools. I'm going to use a tool that I have over here, my next tool over here. And in this particular case, it's a 12 millimeter end mill. That's what I have over here. That's what I like to use. It's as sticking out of the shoulder, out of the holder itself, 30 millimeters. And that's not a problem at all, since the part itself is 25 millimeters in itself. So I have no problem with itself. However, since my cutting length over here is 24, you'll see it'll actually break it up automatically to 2 separate steps. I have my holder defined over here as shown. I'm using 3 flutes. All of the information is here already. I don't have to create the tool. I'll select my tool. If I go into my levels, let's choose my upper level over there, at the 0 point over there. And my pocket, my depth will be up until that point over there. And since I want to go a touch past that edge over there, let's just do a delta of minus 0.5 millimeters to go past the part itself. If I go into my technology wizard, you'll see it was broken up into 2 steps. We have in our technology, we have our offsets over here. And now we'll just do save and calculate. Running our simulation, again, we'll be using the machine simulation for this. So we can get, again, we can get the exact picture that we want. Let me zoom in. We'll run it at the speed over here. You can see it's working on each one of the corners as shown over here. The way iMachine knows how to work, working around the part, then finishing off that entire part on the outside. This is done with the rough cut. Let's just go back to HostCAD for a moment and run it over here. You can see, if I run my HostCAD over here with the stock, you can see the actual tool pass. You can see it going around the part. Everything is fine. If I want, I can add my holder over here so you can see that together with the holder as well. And any kind of crash, if I would have had it, you would have seen that there as well. Okay, now I need to do my finish cut. So I'll just do save and copy. I'll change this to iFinish. And what I'd like to do is use a different tool that I had over here. I'd like to save this as a rough tool. So I'll just choose a different tool. Now, since I don't have another one, I can always create another 12 millimeter tool. And what I'll do, I'll just do simple copy. So I have an exact copy of that tool as far as the length goes. Everything else is all set over here. In this particular case, that's what I want. My levels are the exact same as it was before. My technology wizard stays the same. In my technology, if I go to my iRest area, you'll see that we're working according to the first operation. And we have our technology. In our technology, we have some parameters over here that weren't always talked about. I'd like to talk about it right now. First of all, let me just do a simple save and calculate, and we'll take a look at the tool paths that we have over here. Let's take a look from the top view. And I'll get rid of the holder so we can see the actual tool path itself. You can see the actual entrance points over there, and the exit is actually in the same part, and just going around the part itself. Let me actually do this so you can see this a little differently. And let me get rid of my configuration work on the standard part, so it makes it a little easier to see what we have over here. Now note, we have our entrance and exit point over here, going in an arc, exiting in an arc, exactly the way we need to go. Now, let's talk about the options that we have here, and we can see the following. One, if we want, you can use compensation, because it's a finish cut. Second, we have here something called spring pass. People have asked me what the spring pass does, and spring pass actually just adds another finish cut on the exact same on the exact same pass that we had before, sort of like a second finish cut. Now, we have here something else called lead in out, location at the start of the chain. Note right now it went according to the middle of the part over here, according to the way it figured out its geometry. What I'd like to do is I like to have it go in the beginning of my chain over there where I created my chain. So if I were to change this lead in out location at start of chain, run my calculation, you'll note that my lead in and out now is at the beginning over here. Now, the lead in and out is also very small. Many times people have said they'd like to have this as a larger lead in and lead out, so we can have a, we call large compensation move. Let's run our calculator over here, and you see now that it's larger according to the radius needed over there. Now, one more point that should be noted is that we can now add also an overlap in this point over here just by clicking on large overlap on exit. By doing that, you can see we have an overlap over here, enough to cover the area that needs the overlap over there. Okay, so now let's get now to our next operation that I'd like to work on. Next, I like to work inside this pocket over there. So for that, let's just do now a regular pocket operation, and we'll do again 2.5D pocket, and we'll do the following. We'll create a pocket operation around over here, auto constant Z, and that's all we need. The tool, well, let me see. The radius that we have over here, our smallest radius over here is 8 millimeters. So I'm going to actually use again the tool that I had before, my 12 millimeter end mill for roughing out the part itself. My levels, we have our upper level over here and my lower level down to over here as well. We have our technology. We have our contour over here. Technology. Let's have a wall offset of 0.3 millimeters. If I want, I can have a floor offset. I'll just leave it at 0 for now. And if I go into my link, I like to have a ramping using helical and a lead out using arc. Let's just run our simulation over here. Now use again the HostCAD simulation. You'll see that the tool goes down, ramps into the part, and we have our pocket done over here. Now, one more thing, however, I don't really want to do this in one step. So I'll have my step down here set. Let's put it at every 7 millimeters. So it's going to do it actually in 3 step downs. Again, running my simulation, you'll see that we have our step down in the part, our first step, our second step in a moment, you'll see that as well, and our third step up until that area over there. Now, we can do a simple save and copy now. And I like to change my geometry to this over here to go around that area over there using the exact same tool. No problem, I'll do that. My levels, I'll have my upper level in this particular case over here, since I've machined down to there already. My pocket depth up until this point over here. And the step down will be 5 millimeters. That's fine over there. Actually, let me change my delta depth also to minus 0.5 as well. And we'll change this also 5.5. So we'll do this in one step. Everything else will stay the same. We have our technology, the exact same way before. Our links, the exact same it was before. Running my simulation, again, We have everything machined out already. We're just going to do our machining over there as shown over here. And everything was done over here. Now, doing a finish, no problem. All I have to do is, if I want to do a finish on the first operation over here, no problem over there. I'll just do save and copy. I'll change this to my first pocket over here. This one over here. And I'll just change my tool. I'll change it to my finish end mill. And in my levels, everything here stays the same. But you know what? I'm going to do this all in one shot. So I'll go down. I'll just put this at 0. My upper level will be here. Let's see if I did this correct. Make sure I did this correct geometry over here. Sorry, I took the wrong operation. No problem. It's this one over here is what I need. Okay, that makes more sense. Here we have our upper and lower levels. We'll have this go down in one shot. In our technology, we'll change this to 0. And since I'm going to work only on the walls, all I have to do is go into rest material chamfer, put rest, and instead of separate areas around the profile. Now my previous tool was a 12mm as well. So I'm just going to write in here 13mm just to make a little bigger of an area for the corners. Let's just do our links over here. We have our links. We can have a link of a lead in of an arc. Let's have it. Let's see what's the distance between here and here. The distance between these two areas is exactly 15mm. So let's just give this an arc radius of 15mm as well, make sure it doesn't go down directly on the floor itself. Let's see what happens over here when I run my simulation. The tool will actually go down into the part and finish off that wall exactly the way I want it. And all I have to do right now to keep these same settings, I'll just do save and copy and do the same over here. Again, I'll change this to contour 2. I have the tool that I need. My levels is correct now. And again, over here, my technology, I'll change this here to rest. And in my technology itself, make everything here at 0. Again, my levels exactly the way what I need it to be. My links, I can have this, the lead in over here actually a lot smaller now because I'm all the way inside the part itself. Run my simulation. As you see, my tool goes in and works its way around the part, finishing that the entire area itself. Okay, now I want to start working on this area over here. So for that, if I start my new operation, I want to work in this side over here. I'm going to do this also using the pocket operation as well. So I'll use my pocket operation, and this time I need to use a different MAC position. If I'm not sure, all I have to do is click on coordinate system over here and check the coordinate systems I need. MAC 1 position 2, that's the one I need over there. I'll choose that one. And my geometry will be this chain around over there. Whereas the outside chain, the outside part of the chain, I will mark it as an open edge just by clicking on it as shown over here. So now we have that particular chain that we need over there. The tool, I'm going to use right now the exact same end mill I had before for my roughing. Even though the corners over here is a 5mm radius, I'm still going to use that larger tool right now because that's my roughing tool that I have. I'll just set up my levels. My pocket depth is up until that surface over there, and my upper level is this surface over here. Note when I go into my technology, we now have the option of open pocket. The open pocket is now available to us. Now, First, let's do my wall offset. I'll have my wall offset at 0.3 millimeters. I'm going to leave my floor exactly the way it is. And I'll go into Open Pocket. In Open Pocket, I personally like to work using a profile strategy, where it actually works just like a profile, working like a clear offset on the profile itself. I like to also mention approach from the outside, and I'm not even going to do a link of at all. I'm just going to leave my lead out as none. Let's run the simulation. And as you can see, my tool will just go down into the part itself from the outside, and everything will be done exactly the way I need it to be done. Looking from the top over here, you can see the actual excess material that was left over here. So for that, now I'm going to use another tool. I'll do save and copy. I'll change my tool, and I have here a tool that's, if I'm correct over here, I have here an end mill that's 8 millimeters, and that's enough for me. Okay, I'm going to keep my levels exactly the way it is. I'm not going to make any changes over here. Leave it exactly the way it is. My technology, the only thing I'll change is my wall offset. I'll put this at 0. Okay? Now, since I finished the floor, I had finished the floor already with the previous operation, what I'm going to do, again, in my rest material chamfer area, I'll go into rest, change this to a round profile, and my previous tool diameter will be my 12 millimeter end mill, which I can take directly from my tool over there. And I'll change this to a round profile. Run my simulation. And as you can see, it does everything on that area itself. Okay, now what I'd like to do is, of course, we have our drilling operations over here, but I'm going to leave that alone for now. I'd like to actually continue on to this side over here. And I want to get as much as I can done in this in this webinar itself. So I'm just going to do this pocket over here. Again, I'm going to do a 2.5D pocket operation. And for that, I'm going to change my MAC position to, I believe I'm going to use this one over here. MAC position 3 as shown over there. Showing this pocket over there. That's the one I want to use. I'll create my geometry. Just go over here. I like choosing the bottom of it for the simple reason that by choosing it directly on the chain itself, if I go into my levels, it'll automatically put that value in over there for me. Okay? Again, I'm going to use my tool. The tool I'm going to be using will be that 12 millimeter end mill. My levels I have there as shown before, and my delta, let's go a minus 0.5 millimeters. Now in my technology, I'm going to have my wall offset at 0.3, and in my links, I'd like to do a helical lead in with an arc lead out. Let's see what happens, and it tells me if I can do it or not. You can see the tool will go in, but it's not doing the right type of machining because there's no room for it to do that helical move over there. So I'm going to make this go back to none. I'll use the none option, and you know what? I'll even use a smaller end mill for this, for that particular purpose. I'll use my 8 millimeter end mill for that. Run my simulation. It's going in a none. Note that when I do none, it goes up until 2 millimeters before the top of the surface over there, and then goes directly into the part at the feed rate for my Z. Okay, it's doing that. It's doing the machining around there. Now, one thing, however, is that many people do not like to go directly into this part itself. What they'd like to do, if they don't have room, is to actually drill a hole. So what I'm going to do is I'm going to create a new operation. Now, do I know where the tool went in? The answer is I don't know the exact. That was determined by the program itself, where the exact entrance point was. Well, what I'm going to do is as follows. I'll go into 2.5D, create a drilling operation, and note, I'm in Mac 1 position 3, the same position that I created the pocket itself. If I go into my window that has all the different geometries for the drilling, and I didn't create one yet, you'll note that there's a geometry there automatically for that particular pocket. In other words, the system knows where the end mill went in, so it automatically creates a drill point for it as well. All I have to do is choose the proper tool that I need. I'm going to use a 10 millimeter end mill. Drill. My levels, my drill depth will be up until the very bottom of that area over there. And I'm going to use the option of full diameter, having the full diameter going down to that depth. Of course, we have our technology, whichever we want to use. I'm going to do save and calculate. Note what happens over here, in this area over here, when I do save and calculate. You'll note that the drill is automatically put in before the pocket. This operation is associated to the pocket itself since I used the geometry that was created by this. So it'll always keep it before the pocket itself. If I go into my pocket if I go into simulate, go directly to my pocket operation and simulate from there, you'll note that there's a hole there already created from the drilling area over there. And it goes directly into that area. Now, there's one more pocket I'd like to create. The one on the flip side over here. Now, this particular part that I have over here is actually symmetric. So this pocket is exactly symmetric to that pocket over there. So instead of creating another operation, what I'm going to do is I'm going to choose these two operations that I have in Mac 1 position 3, right click, and instead of creating a new operation for the other side, I'm just going to tell it transform. And in my transform, I'm going to use the option of 4-axis. By doing that, I'll say include the original operation. My angle, I'll put it at 180 degrees, insert. You note now it'll be working on two different angles. It's 0, original one, what I marked in here, include original operation, and it'll then flip it around 180 degrees. Let's click on OK. And you note that we have the 4 next to it showing that it's a 4th axis operation. Let's run our simulation now on the entire part. And I'm going to use the machine simulation for that. Okay. Now, we have our first operation over here. Let me just run this a little slow so we have our first doing the face. Now we have our iMachining operation as shown over here, as I showed you before. Okay. Continuing on over there. Now note, by the way, this is one of the questions that was asked me. Why did and when I did the first operation over here, I marked my first chain as open. Because it has to know that since it works like a pocket operation, it has to know that it has to come in from the outside. That's why my first chain was marked as an open chain. I believe that's one of the questions I see over here. Okay, as it's going in over here, it's doing its pocket over there. Let it continue down. And now, as you can see, first it's doing the operation. Let me actually slow this down a bit. And it's first doing the operation on this side, this pocket over here. You see it also already drilled out both sides first. Went a little fast. Let's go a little quicker. Now it's going to actually go up in a moment. Flip around to the other side as shown over here, and then do the pocket on the other side. So instead of creating another pocket operation over here, I just did the transformed and rotated it around the axis over there in order to do that pocket as well. Since this particular part is symmetric one side to the other, I was able to do that over there. So I use that to my advantage as well. Okay. The rest of the operations, as far as drilling goes, that's the exact same way I have it. If I continue on with the rest of the part, it will take a little bit too long if I go into every single detail of it. But I understand, from what I feel is that you understand basically what I did here inside the webinar. We first, just to recap what I did over here, we created first our stock. And I used a 3D stock in this particular case. I created it in the part itself as a different configuration. There may be a question people may be thinking in the back of their mind is, can I create this as another part and add it as an assembly? The answer to that is, of course you can. You can create this as another part, just bring it in here as an assembly and mate it. Which way is better? That depends. If you are the one that controls everything in your part, you can make the changes to your part, or it's a one-part deal, or whatever, and everything can be done by you. Then I like to do it inside the part itself. It's a lot quicker and a lot easier. If you are a job shop that gets everything from the outside, and what happens is that many times you'll get a revision, the part itself. It's a lot easier then to work inside this, creating a separate stock according to the assembly itself, and work that way. This way, if you change a part, you don't have to worry about your stock disappearing because it's not part of that new part. Okay, so as I said, we have the stock that I created. I showed you how we work on creating different multiple sides as far as the coordinate systems. We went over also defining our fixture and in the machine setup as well, and choosing the proper operations that we need for the pocket, for the parts itself. And of course, we also did show one of the cases of how we can use transform inside the part itself. Okay, just to go over, I see we have one question. I hope I answered it, but just to make sure. There's a question here, when doing the second face, actually I didn't do a face, I only did one face operation over here. This was the top, but I think you were talking about the eye machining operation that I did over here. When I did the second operation, I created 2 chains. My first one was open. The question is, why did I create that first chain that is open? Going into the operation itself, let me just go into my geometry and do show. This chain, the outside chain must be marked as an open chain because I have to enter this area from the outside over here. Therefore, this entire chain must be marked as outside. If this is an internal, then the tool cannot fit in between these two lines. But I wanted to work from the outside in. Therefore, I marked this entire chain as an open chain. Okay, that's basically the end of our webinar. Again, the webinars will be on our website. If you want to know exactly where on our website, we can go into our website. I'll just bring it up to you in a moment. You can go into our website, and inside the area of webinars, we have webinar recordings. And we always have the last 4 recordings over here. Plus, on the left-hand side, we have all the previous recordings that were done in previous webinars. And as of January, all of the webinars that we've done, we're including the option of downloading the video underneath each webinar that was done over here. All you have to do is click on the webinar you want to see. You have to download the video itself, and you can also download the parts that were used in the video, in the webinar itself. Okay, thank you everyone for joining the webinar, and have a great weekend.